Question 8. 4 pairs of solutions are mixed. Which pair of solutions form a white precipitate? So these are the 4 pairs of solutions, and we need to find out which one is a white precipitate. Well, so the first one here is sodium ammonium chloride and sodium hydroxide. If we react the two together, we should get NH3, right? If you react that plus that, you get NH3, because the H, this will form sodium chloride, NH3 plus H2O plus sodium chloride. And is that balanced? Yes, that's balanced. And this is a clear solution because sodium chloride is white, this is salt, but it dissolves in water. And you know when salt dissolves in water, you cannot see the salt, it's just clear. So that's aqueous. So that's liquid water, and ammonia is a gas, so that escape. So that's a gas. If I write it here, the reaction, ammonium chloride, it's an aqueous, plus sodium hydroxide. Again, that's aqueous. Well, that actually will form ammonium, all right, hydroxide plus sodium chloride. But the ammonium hydroxide itself, which is an aqueous, will dissolve to form ammonia plus water. And water is liquid. This salt will dissolve in water. Okay, the salt will dissolve in water. This is a gas, so that will escape. So that's not what we want. That's not going to be a white precipitate. Potassium bromide and silver nitrate. This is a popular reaction. Well, silver. So you're going to get basically silver bromide. So you're going to get silver bromide plus potassium nitrate. Right. Again, this one is going to be solid. It's a precipitate and it's yellow. So that's yellow. This is yellow, right? So it won't be that one because this is yellow. Iron chloride and ammonia get aqueous. So ammonia dissolves in water. So iron chloride. Well, so this one is a bit tricky. So let's write that here. Iron chloride, aqueous. That means in water. That's chlorine. So that's in water. That's why it says aqueous. Plus ammonia, NH3. Again in water. So there's a lot of water around. In that case, because there's water around, if you like, just put water there. You basically will form iron hydroxide, right? So you can get iron hydroxide, OH, and that'll be 3, because the iron is dissolved in water. So the aqueous means water around, and then plus ammonia. There's an H out of that. That H will go to there to form ammonium chloride. All right. ammonium chloride. So that's just one Cl, by the way. Well, because the ammonium chloride will be because you get 3 Cl here. So if you balance this equation, you could balance it actually. So if you balance this equation, you're going to get, let's balance this so you can make sense of it. You got Cl3 here. So all you need to do is just put 3 there, isn't it? Because I'm going to put 3 there. So if I cancel that one to make sense of it, so you're going to get 3NH4Cl. NH4 is plus, Cl is minus, so that makes sense because you know NH4 is plus, and Cl is minus, so they make sense, they form together. We got 3 chlorine here, so that's why I have to multiply that by 3. And that means that I have got there's another hydrogen here, right? Iron is okay. The OH has got 3 there. So I'm thinking there are 3 waters here. So that makes it 6. 3 times 2 is 6. I've got 3 here, and I've got that one, and I've got 3 of those also here, because 1 extra is gone there, and three of those is gone there, so it's balanced. So we can balance it actually if we want to count it. Conservation of mass. Fe, Cl3. If you count how many H's here, 3 times that's 9. 9 plus 6 is 15. So let's count how many H's here. 3 times 4 is 12. 12, 13, 14, 15. So that's balanced. The H's are balanced. Okay, that's a strange one. But this will form aqueous solution. So that's aqueous. And so therefore you don't, this is not white. The final one here is the Cr. Yeah, so this one is Cr chloride. That will form Cr chloride. And Cr is 3 plus. Therefore it's going to form 3 chlorine because that's 3 plus. Plus barium sulfate. Barium is plus 2. And sulfate is 2 minus. So that balances out. So that's what that will form. Because we've got, and if we balance this equation, we've got 2 of these. So if I stick 2 there, because there's 2 chromium, and the barium, and there's 2 chloride. So I have to put 3 there. And so that means there will be 3 there. So that's because there's 3 sulfate. So that's balanced. So that's actually, but this one is white. The barium sulfate is white. So that's why this is solid. That's a white precipitate. So that's the answer to that one. It's D.